Hi students, in this session I am going to discuss very important application related to the relative motion, that is Rayman concept. So first let us focus why do we consider relative motion in Rayman concept. First focus on that. After that let us see the simplest method, right, to analyze Rayman related applications. See guys, in the previous video, same relative motion, we have discussed riverboat concept, where I have taught you three different cases. And as far as JEE Mains and Neet are considered, most of the questions will be covered from those three cases. In a similar way guys, here in this Rayman concept also, I am going to take again three very important cases with the help of which you can solve almost any problem related to Neet as well as JEE Mains level. Of course, for advance you need to take some more in-depth concepts, but this lecture is only targeting Neet as well as JEE Mains. And that too I am going to give you very much simplified methods to solve almost any problem up to JEE Mains level and Neet. Right guys? So let us begin. Here you will be having three types of velocities. One is velocity of man with respect to the ground. Next one is velocity of rain with respect to the ground, and next one is velocity of rain with respect to man. Since this velocity is present, we are taking our concept to relative motion or relative velocity, because velocity of rain with respect to man. So normally students, when the man is at rest, then VRM will be 0. Therefore, to protect from the rain, the man has to hold umbrella along the direction of the rain. That's it. The discussion ends over there. I repeat guys, when man is at rest, then if you want to protect from the rain, then he has to hold umbrella in which direction? Velocity of rain. Like if rain is falling vertically downward, then the man has to hold umbrella in vertical direction. Otherwise, if the rain is inclined at some angle, then in that case the man has to hold umbrella at that inclination. In the similar way, if the man is moving, I repeat students, while raining, if the man is moving and he wants to protect from the rain, then in this case the man has to hold umbrella along the direction of VRM, right? If he holds along VR, then he can't get protected from the rain, right? To overcome rain or to get protect from the rain or not to get drenched, he must protect, he must keep umbrella along the direction of VRM. So if you consider a moving man in the rain, then compulsory to keep the direction of the umbrella, he need to know this direction, or one need to know this direction. So in this topic guys, totally we are going to focus on identifying VRM. That's it. Okay guys. So now if we take, see, I am considering VR is the velocity of rain. Okay. And let's consider this velocity of rain in the first case. Okay guys, in the first case, rain is falling vertically downward. You take like this. This is the velocity of rain. Okay guys. Next. And let's consider the man is moving horizontally. This is the velocity of man. A simple case I am taking, where rain is falling vertically downward and man is moving horizontally right. And if you take the concept of VRM, velocity of rain with respect to man, then this can be written as Vr minus Vm from the knowledge of relative motion. In vector form, every time we will write Vrm is equal to Vr minus Vm. So now to identify the direction of Vrm from the knowledge of this vector, students, if you want to identify this direction, you must consider negative vector, because this can also be written as Vrm is equal to Vr minus of, right, or plus minus Vm. You just make use of the knowledge of addition of vectors. This is the resultant vector, right? Vr minus Vm is nothing but you can write it as Vr plus of minus Vm. And here you will make use of, right, addition of vectors to identify these velocities on the triangle. Right, see, in order to find out Vrm in this figure, what do you know, guys? You need to know this one, that is negative vector of Vm. That's why, students, when you draw or when you take velocity of rain, velocity of man, and velocity of rain with respect to man in the form of a triangle, right, you always consider negative vector of Vm, because here minus Vm is there, no, you need negative vector, right? So here, in the same situation, try to analyze. So this is Vm is moving horizontally right. So now, if you represent on a triangle, then this will be Vr, vertically downward, and take this is Vm. So obviously, this will become what, students? Minus Vm. I have considered the negative vector. To find out Vrm direction, here I have taken the negative vector. Right, students, this is Vm and this is minus Vm, and this is Vr. Now draw the line, because we know that, guys, from triangle law of addition, if you take a vector like this and if you take another vector from the end point of the first vector, listen, guys, here A vector is taken along this direction and B vector is drawn from the end point of A vector. Now the resultant vector is always drawn from the starting point of first vector to the end point of second vector. So this would be the resultant vector, and you will write resultant vector in its simplest form as A plus B. That's it. So this is extremely the simple idea of understanding the vector addition. Of course, vector addition is nothing but resultant vector. Right, students? If you take vector along the side of a triangle, vector A, and vector B, which is drawn from the end point of vector A, then resultant vector can be drawn like this. R is equal to A plus B. Now by following this same rule, students, here, what I am doing is, here I took minus Vm, because see, guys, Vrm is Vr minus Vm. So we need negative vector. Negative vector is nothing but having same magnitude of a given vector but opposite direction. That is a negative vector. So negative vector cannot be defined independently. Negative, for a given vector, you can write negative vector just by reversing its direction, keeping the same magnitude, right? Now, so come back to here. I'm taking, this is a direction. Now, Vrm can be drawn from the starting point of first vector to the end point of second vector like this. This is going to be the Vrm, that's it. But this is minus Vm. This is 90 degrees. That's it, guys. But here the man is moving horizontally right. But for finding Vrm, this is the thing. Let us consider it is inclined at an angle theta. Now see, guys, Vrm is equal to Vr minus Vm. So this is treated as the resultant, which is written as Vr plus Vm. But plus into minus, minus. So that you will get like this. That's it, guys. This is the simplest way of understanding how to write down the vectors, how to write down the velocity of man, velocity of rain on a triangle. Because here you are having three vectors or three velocities, right? Now, see, guys, this is Vrm. Now, if the man wants to protect from the rain, then he has to hold umbrella in which direction? Vrm, but not along Vr. This is Vrm direction. So, a moving man towards horizontally right has to protect umbrella at an inclination theta to the vertical when the rain is falling vertically. Listen carefully, guys. When the man is at rest, then he has to hold umbrella directly in vertical direction. But when the man is moving horizontally right, then he has to hold umbrella at an inclination theta relative to vertical. That's it, friends. And for calculating theta, since it is representing a right angle triangle, we will make use of what? Tan theta ratio. Tan theta is equal to what is right, friends? Opposite. Opposite is magnitude you need to consider. Right? Mod of Vm by adjacent Vr. Like this you can take. So this is a way of calculating the direction. Or else theta is equal to, you will write tan inverse, right? Vm by Vr. That's it. This is a way of identifying the direction of umbrella, along which it has to be kept to protect from the rain. Sometimes you will be asked this same angle with horizontal, let it be alpha. In this triangle, if you were asked to find out, right, the direction of VRM relative to horizontal, students, then in this case you will write tan alpha is equal to, this is written as opposite by adjacent, VR by VM, that is mod of VM. Or else you can even write here alpha is equal to tan inverse, right, VR by VM. That's it. This is very, very important. So now see, students, for finding the direction of VRM, this is one approach and this is another approach. Approach in the sense, this is relative to vertical, this is relative to horizontal. That's it, guys. But here we have assumed that rain is falling vertically downward. Clear? So that man is moving horizontally right. A simple case we have chosen. Just for understanding how to apply the mathematical part, especially the triangle method. Usually, students, you can make use of vector method also. See, VRM in vector form is equal to VR minus VM, no? Even you can use vector form also, but listen, as far as applications related to Neet and JEE mains are concerned, you may not require the vector representation. But if you are really very good at vectors, you can try. But listen, the basic, like easy to moderate problems, right, will be solved only with the help of the triangle. By drawing the triangle, if you draw the triangle in the correct way, then in 2 steps you will get the answer. But in the vectors, right, you need to focus, like you need to spend some time in the simplification. But listen, guys, whenever the situation is complex, in depth, then their vectors really help us. So while doing a session on advanced problems, I'm going to show you the vector related applications. But here I just wanted to make you familiar with only triangle based applications, so that your requirement will get fulfilled. Like up to JEE mains, Neet and all exams will be having applications which can be solved only by using triangle. Right, guys? So this is extremely basic method by using the triangle. Let us take some different variations. General case. General case in the sense, here I considered VR vertically downward. What happens when VR is not vertically, if it is inclined at an angle theta? So now see, guys, this is extremely easy concept. And next I'm going to show you 3 standard concepts which will help you for solving the problems easily, as well as understanding, right, the direction of velocity of rain with respect to man easily. Right, friends? Let's take. So see, guys, let us consider here, as I have told in the starting of the class, I am going to describe the situation, almost all the situations related to rain man concept in 3 different ways. In the first way, case 1 I am taking. Here let us consider the rain is inclined at an angle theta like this. Let's consider here, this is the direction of velocity of rain. And consider the man is moving horizontally like this. Okay? Right. Okay. So students, when you represent I repeat students, when you represent any vector along a triangle, then keep in mind that length of this side directly gives magnitude of that vector. Vector may be velocity, acceleration, force, etc. Any vector, if you consider along the side of a triangle, then the length of such side directly gives its magnitude. Okay? So you can consider the length of the triangle or the side of the triangle as the magnitude of the vector taken along it, right? So here I am taking, this is Vm students, velocity of, or Vm1 I am taking, right? Vm1. Because see guys, before entering this I just wanted to show you one more important logic, that is Vrm is always written as Vr minus Vm, and we are drawing triangle according to this situation by considering a negative vector of Vm. Because in these applications we are much concerned with Vrm direction. So in order to find the Vrm direction, Vr minus Vm, that means negative vector of Vm. Now in this case, keep in mind that guys, Vr remains constant, velocity of rain with respect to ground, right? It is not dependent, it is independent. We cannot control, what I mean to say here is guys, we cannot control Vr. Velocity of rain cannot be controlled, is it or not? Okay, when the rain is falling during cyclone, heavy rain falls. So till now there is no method of controlling the velocity of rain. Therefore guys, in Vrm, Vr cannot be controlled. It is independent, right? It's constant and independent. It's not in our hands. We can't do anything. Right. Now, this is directly independent guys. Now, but if you take Vm, Vm can be controlled. Velocity of man himself can increase his speed or decrease his speed, or he can maintain a constant speed, or he can keep himself at rest, right? Since the man himself acting as the observer, he can increase his speed, decrease his speed, or he can keep his speed 0, due to which Vrm can be affected. So the value of Vrm can be changed, or the value of Vrm can be increased or decreased by varying, changing the value of Vm. But Vr will be constant. Let us take a situation guys where I want to take Vr is equal to some 12 kmph I am taking. Just it's an assumption. 12 kmph I have taken, right? Vr is equal to. Now, and Vm is equal to, initially you take this is some 6 kmph, right? Just assumption. Velocity of rain is 12 kmph and the velocity of man is 6 kmph, right students? Next, suppose if Vm increased gradually, right? Initially Vrm will be, what do you expect here? Approximately it is 12 minus 6. So I'll be getting 6. But again you see 12 minus 5, it will be 7. Or else you take 12 minus 8, it will be 4. Now focus here guys. On increasing Vm, here Vm is 6 to 8, Vrm decreased. Listen carefully guys. On increasing, for this assumption where Vr is greater than Vm, in this case, on increasing Vm gradually, what happening to Vrm? Decreasing. If you take instead of 6, 7, it will become 5. 8, it will become 4. 9, it will become 3. So listen, keep in mind that this is very important logic, with the help of which we are going to represent, right, Vrm as well as Vr and Vm in the form of a triangle. Because if you can able to represent the given situation correctly in the form of a triangle students, almost 70% of the problem will get complete. Only the leftover part is to make use of geometrical rules related to the triangle, followed by 2-3 steps simplification. That will give you the answer. Fine? Okay. Next, in this, we can conclude that Vrm can be increased by decreasing Vm, or Vrm can be decreased by increasing Vm. Condition is when Vr is greater than Vm. Right friends? So I'm going to make use of this condition for drawing the triangle. Right, here Vm1, I'm taking M1 is the speed of the man in the first case. In the first case, let's consider Vm1 is the velocity of man with respect to the ground or absolute velocity. So now try to take exactly, this is from here to here, it is Vm, no? So almost I'm taking the same length, almost, right? So this will become what, guys? Minus Vm1 negative vector. Why do we need negative vector? To write down the direction of Vrm, right? Here you see. Okay, listen. I just wanted to take a different color, right? Here I'm drawing like this, students. This is the line taken from here and touching this. Then as per the right here, if you take Vr is making an angle theta with the vertical. So theta is equal to, let's consider it is the direction of Vr with respect to what, guys? Vertical. It's okay. Next, consider this is alpha, right? Alpha is nothing but it is Vrm1. Listen, because students, from here Vr is drawn in this direction and a negative vector of this taken in this direction. Then Vrm1 is drawn from starting point of Vr to the end point of Vrm1. So that this is the direction of Vrm1 in the general case. Listen, guys, in the general case you can take this as the direction of Vrm1. Listen carefully. Sit there. I'll come. This is already completed topic. You just keep practicing. I'll come and join in 10 minutes. Right. See here. This is Vrm1 and this is the negative vector Vm1. Now I repeat, students, listen carefully. Here we have considered a situation where Vr is inclined at an angle theta with respect to the vertical and man is moving horizontally right with speed Vm1. Try to represent negative vector of Vm in this direction. Then if you want to write on the direction of Vrm1, this would be the direction of Vrm1. Let us consider Vrm1 is making an angle alpha with the vertical. So you take this as A, this as B, this as C and this as D. And AB is equal, let us consider some Y, and BD is equal, let us take this is X, right? So listen, in triangle ABD, I have considered this is AB is equal to Y. Y is any parameter like length. Okay. Suppose if it is velocity, Y will represent magnitude of velocity. If it is force, Y will represent magnitude of the force, right? It is just the parameter considered along AB. And next BD. So BD will be X I am taking, right? These are the standard assumptions. Now, so that from here I can even write BC is equal to, you see here, BC can be written as, this is a part BC, no? So this is X I have taken. So BC can be written as X minus Vm. That's it. This is only BC will become X minus Vm1. This is Vm1. Right. Okay, you will take this as X minus Vm1. Right. This would be BC. Now try to make use of the triangle, guys. Here, if I take ABC triangle and theta is Vr with respect to the vertical and alpha is equal to, I am taking Vrm1 with respect to the vertical, right? I am taking vertical as the reference, guys. Now look over the figure. Then if you want to take tan alpha, or else first I just wanted to take tan theta. Tan theta in triangle ABD, right? Tan theta in triangle ABD I have taken like this. This is ABD I have taken. Then wait. Right, in triangle ABD, tan theta can be written as opposite BD by adjacent, that is AB. So tan theta can be written as opposite is BD, no, x by y. So take this as first equation, friends. If you know x and y, then you can calculate tan theta easily. And again in the triangle ACB, see, in triangle ACB, look at the figure, guys. I just represented VRM, right, VR minus VM on a triangle by considering direction of VR at an inclination theta to the vertical. Fine, right, in this triangle ACB, so this is tan alpha is opposite by adjacent. So you can write tan alpha is equal to, what is opposite here? Opposite is BC. So BC by, next adjacent is AB. Right. So here you can take in this way, tan alpha is equal to BC by AB. Alright, next. Okay guys, see. Now, since tan alpha is equal to BC by AB, here I can even write tan alpha as BC is equal to, you can take x minus VM1 by AB is y. Or else guys, here I am writing its value, that is, this is the first equation, and alpha is equal to tan inverse. Tan inverse, you can write it as x minus VM1. You can write like x minus VM1 by y. This is alpha, students. So take this as second equation. Just before we have seen that theta is equal to tan inverse, right, x by y. So this is the situation. So this is the first and this is the second. With the help of these two observations, you can calculate whatever is required in the given situation. I hope you understand, students. Focus on this. In this situation, if you know either x or y, or if you know only x but not y, and VM1 is given, then alpha and theta, that all can be simplified. Definitely, students, you will be given the necessary data to solve this kind of problem. But after taking down the data, you need to represent correctly in the form of a triangle so that VRM1 can be identified. Right. Now, here my question is, students, this is okay, fine. VRM is equal to VR minus VM1. Next, I want to consider the velocity of the man as VM2, whose value is greater than VM1. I repeat, students, this is VM1, no? So this I have taken as VM1. If I increase the value of VM1, increase in the sense man started increasing his speed. I repeat, students, man started increasing his speed. Listen carefully, all of you. Alpha is the direction of VRM1. And now, if VRM1 or VM1 is increased gradually, VRM1 decreases. See guys, here in the starting of this case 1, I have explained that VRM depends on the value of VM, because VR will be constant. On increasing VM, velocity of the man, VRM can be decreased. And on decreasing VM, VRM can be increased. Right, students? So therefore, basing on that, if I increase this VRM1, see, if I increase the value of VM1, right? Here if I increase the value of VM1, the C position will get displaced towards B, no? Because this should be increased. Right, friends? The length of the triangle, this triangle DC will increase. Listen, friends, on increasing VM1 gradually, this side, automatically its negative vector also increases towards left side. Increase in the direction of VM1 towards right results in the corresponding increase in negative vector towards left. So that this will increase, due to which alpha will decrease. Alpha, let us consider alpha is the direction of VRM1 in the considered case. Now on increasing Vm gradually, velocity of the man, alpha decreases. Try to understand this concept correctly, students. On increasing velocity of the man, alpha decreases. This is a conclusion I have taken from there. This is a conclusion I have taken from this figure. The main motto of taking this case is, students, to make you understand that on increasing velocity of the man, alpha can be decreased. So let us consider a situation where, listen, on increasing this speed, on increasing velocity of the man, this length will increase and C displaces towards B, due to which alpha decreases. That is the case I am taking. Now I have considered a case here where case 2 you take. Case 2 I have taken the velocity of the man as Vm2, which is greater than Vm1. And due to which what happened here is, so this is Vr inclined at an angle theta with the vertical, this won't change. And here this I am taking Vm2. So here Vm2 is greater than Vm1. In the previous slide, we have seen that, students, on increasing Vm, alpha decreases. Now I am considering a case, right, where Vm2 is the velocity due to which Vrm2 becoming vertical, alpha decreasing and becoming 0. This is a case I am considering where alpha becomes 0. Means Vrm2 becoming vertical. Right, friends? In the previous case, Vrm1 is not vertical. Vrm1 is inclined at an angle alpha with a vertical. But in the present case, right, I am taking Vrm2 vertical. Means here alpha became 0 due to increase in the velocity of the man. Very important consideration, students. If you understand this correctly, you can excel in your like applications related to Rainman concept, right, students? At Vrm2 or at Vm2, Vrm2 became vertical. So if you take this is point here, try to take the previous one where I have taken A, B, D. So position of A, B, D remains the same, won't change. Only C is overlapped on B. Right here, C relative to the case 1 overlapped on B. That's it. Due to increase in the speed of the man, this you can write it as a note for even better understanding. Due to increase in the speed of the man, this you can write it as a note, guys. Now BD is X and this is Y. This is our standard assumption. So in this again tan theta won't change. It will be X by Y only. So we can't change this equation. But listen, Vrm2 is taken along vertical. So definitely from dB represents, this will represent directly Vm2. That is minus Vm2, students. Okay. Here you can take this as, in place of X, I can write this as minus Vm2, negative vector. That's it, students. Or X. X is a normal assumption, right? So here X and Vm2 almost have same magnitude. And theta is nothing but alpha here. Sorry, not alpha. Alpha is 0. So this is Vrm2. Then tan theta can also be written as in this figure. Opposite. Opposite is what? Mod of Vm2 by adjacent. Y you can write. Otherwise, students, if you know the theta, if theta is given, for example, then sin theta can be written as opposite by hypotenuse. And if you know sin theta and Vm2, then Vr can be calculated easily. Like this, you will write the different variations according to the requirement. According to the given data of the question, students, you can write down the different variations. Right guys? In the previous case, velocity of rain with respect to man is inclined with the vertical. In the present case, velocity of rain with respect to man is along the vertical. Why do this happen? Due to increase in the speed of the man. That means on increasing the speed of the man towards right, alpha relative to vertical decreased and became 0 at a specific value, Vm2. Right. Now students, I just wanted to show one more variation in the same figure. One second. Right friends, I am keeping this as it is. Now I want to take case 3. In case 3, I am taking a situation where Vm3 is even greater than Vm2. Means the man has increased his speed further. In the initial stage we have taken Vm1, where we got direction of Vrm at an inclination alpha with the vertical. In the case 2 we took Vm2, where we got Vrm direction along vertical. Now if you increase the speed of Vm2 further, like Vm3, consider a speed, then listen, I am just representing the situation on a figure. Try to understand this. This theta can't change, Vr can't change because it is not in our control. This is A, this is B, and this is D. These three can't be changed. Now velocity of man increased. This is Vm3. So this side obviously, this will become minus Vm3. We need negative vector to represent what students? Vrm. So that if you draw a line from here to here, then this will represent Vrm3. Now listen guys, again let us consider this is some angle alpha only. Again alpha. So now see students, on further increasing here, this entire thing is, I am taking this is C because C got displaced, no? Earlier in the first case C somewhere here, next overlapped with B, now displaced from the B towards left side. Okay, then this entire thing can be written as Vm2, magnitude of this one. So I want to keep minus also. This is. Now here completely DC is Vm2. And from B to D we have taken this is X. Then BC will become what students? This will become Vm2 minus X. That's it. And this is Y will remain as it is. I have represented the present situation on a triangle. Right friends, here CD is equal to Vm3. Therefore BD is equal to, you can write, BD is X already we know it very well, and AB is equal to Y, these two we know very well. Therefore BC can be written as, here BC is equal to only this one we need know. From D to C this is entire Vm2, right? Listen guys, D to C this entire is Vm2 and BD is X and AB is Y. This is a starting assumption itself. Then BC is equal to, you can write Vm2 minus X. Right. Now see, here we can say that. Just focus on alpha itself friends. For understanding effectively case 1, case 2, case 3, just focus on alpha. Here alpha became 0, right? But here alpha increased in reverse direction. Reverse direction means in the earlier alpha is inclined with vertical, but on that side. If you want, I'll show you. Check it. See friends, this is the first case where alpha is. Right. This is a case where alpha is given here students, alpha. When the speed of the man is Vm1, alpha is inclined with vertical. Right. This is the present case. Now speed of the man is increased, then alpha will decrease. Why? C displaces towards B. On increasing the speed of the man, length of CD increases and it displaces towards B. And we have considered a case where C overlapped on B, because on increasing Vm1 further guys, what happened? C increases and overlaps on B. We have considered that case where C overlapped on B. Therefore, alpha will become 0. I assumed Vm2 is the speed at that instant. Then the necessary geometrical part, mathematical part I have drawn here. Next you take case 3, where further the man increased his speed, due to which alpha increased in the reverse direction. Earlier alpha non-zero became 0 and increased in the reverse direction. Therefore, students, in all these 3 cases we can conclude that, listen carefully, in all these 3 cases we can conclude that, of course here again you can take tan theta is here same. Tan theta is equal to opposite by adjacent x by y. This is standard form. Sin theta is equal to x by v or whatever it may be. And but tan alpha is equal to here. Because with the help of the suitable geometry, we are going to simplify the related thing, right? Tan alpha will be opposite. Opposite is Vm2 minus x. Vm2 minus M3, guys. Not M2, M3 this is. Vm3. We have considered it as Vm3, na? Greater than Vm2. Vm3 minus x by y. That's it. Okay, these 2 are the observations. Anyway, guys, you are really very good in simplifying this one, triangle based geometry. So no worries at all. So here alpha increased in the reverse direction. Now you just keep all the 3 situations together and analyze. In the initial case, man has to hold umbrella like this to protect from the rain, like this, to protect from the rain. And he has to keep the umbrella vertical when the speed is Vm2. At Vm1 speed, since alpha is inclined, like this, guys, at Vm1 speed, alpha is inclined. This will be the alpha when the speed is Vm1. And now see, here alpha became 0 when the speed is Vm2. And alpha increased in reverse direction when the speed is Vm3. I have represented everything on a single figure. See, guys, you just focus on the nature of alpha. This is alpha, this is Vrm1, guys. These are the conclusions we have seen in all the 3 cases. Here this is Vrm2, right? And this is Vrm3, right? So this is Vrm3. In all the 3 cases, focus only on alpha, guys. Alpha is initially like this, then became 0, then increased in this way. Therefore, initially the man has to hold umbrella like this to protect from the rain. Then he has to rotate like this, and then he has to rotate like this. That means, listen guys, in which direction the man is rotating the umbrella. Earlier it is like this, next this and this, in clockwise direction. Very important conceptual bit. On increasing the speed of the man gradually, the man has to hold umbrella, the man has to rotate umbrella. In which direction? Clockwise direction. That's it, friends. This is very simple. The entire magic lies in VRM. That's it. If you're able to understand VRM correctly and behavior of VRM, which is going to be dependent on VM, on changing VM, VRM also changes, right? Accordingly, alpha changes. Alpha is what? Direction of VRM with respect to vertical. Understood, guys? You will be getting a conceptual question basing on all these things, like on increasing the speed of the man gradually towards right, in which direction the man has to rotate the umbrella if initially rain is falling at an inclination theta with the vertical. The most frequent and usually asking conceptual bit this is, right? The man has to rotate umbrella in clockwise direction, because first case, second case, third case. Suppose if rotation of the umbrella is not asked, some other parameter, like you will be asked VR or you will be asked VRM, whatever it may be, that can be solved by using the simple triangle based geometrical formulae. Right, friends? That's it. So these 3 cases helps you to solve almost all applications related to like Rainman concept up to JEE mains level. You will be having some more variations in the advanced, students. So this class will be only for Neet aspirants as well as JEE main aspirants. I'm going to take some extra applications related to advanced in the upcoming days. Thank you, students. Thanks for joining the class. Good day.